At the beginning of 2025, astronomers noticed a faint spot moving so fast that it was immediately clear it was not bound by the sun's gravity. Its orbit was not an ellipse like that of ordinary comets, but a hyperbola, a trajectory that bodies follow when passing through the solar system only once. It was the third known object from interstellar space. After the famous Oumuamua and Comet Borisov, 3 Iatlas appeared, detected by the Atlas telescope in Hawaii. From the very first weeks, it was obvious that this comet was unlike any other. Astronomers expected it to behave like a typical icy body, melting as it approached the sun and leaving behind a long, dusty tail. But 3 Iatlas was different. Its tail was not just long, it grew toward the sun. Not away from it, but toward it. Images captured by the Gemini South Observatory revealed a powerful jet of gas streaming inward toward the solar system. It was as if the comet were trying to expel something, responding to the sun's heat not like ice, but like some other, more complex material. When the James Webb Space Telescope turned its mirrors toward 3 Iatlas, astronomers expected to see familiar spectra: water, a bit of methane, ammonia, carbon monoxide. But the spectra revealed something else. The main component emitted by the comet was carbon dioxide, CO2, in proportions never observed in any comet of our solar system. Normally, water is the primary ice that sublimates when heated. Here, water was almost absent. It was as if this object had formed in a completely different chemical environment, where water was rare and carbon dioxide formed the backbone of frozen material. This led to dozens of hypotheses. Some scientists suggested that 3 Iatlas might have been born in the cold outer regions of another planetary system, where temperatures were even lower than in the Kuiper Belt. By mid-2025, as the comet approached Mars' orbit, its activity suddenly intensified. Telescopes recorded that the coma, the gas envelope surrounding the nucleus, had grown several times in size. The tail of 3 Iatlas stretched for millions of kilometers, and the dust stream became so dense that instruments detected flashes of reflected light even from Earth's distance. European orbital stations Mars Express and ExoMars TGO had a rare opportunity to observe the comet from Mars' orbit. The distance between them was about 29 million kilometers, nearly 75 times the distance from the Earth to the Moon. Even from such a distance, instruments detected faint ultraviolet signals from its tail. When scientists compared observations from different observatories, they noticed that the comet's trajectory deviated slightly from a purely gravitational path, as if an additional force were acting on 3 Iatlas. This phenomenon has been seen in other comets, when reactive gas jets create microscopic pushes. But for an interstellar body composed mainly of CO2, these jets should behave differently, and this could hold the key to its internal structure. Calculations show that the comet will still remain on a hyperbolic orbit and leave the solar system forever. After all these discoveries, the International Asteroid Warning Network, IAWN, announced, for the first time in history, a global observational campaign for an interstellar object. From November 27, 2025, until the end of January 2026, observatories around the world tracked 3I Atlas across all possible ranges, from optical to infrared. The goal was to obtain the most accurate astrometry and spectral data to understand which star system this traveler had come from. The Hubble Space Telescope helped refine the size of 3I Atlas's nucleus. According to NASA estimates, it did not exceed 5.6 kilometers, but it could be even smaller, around 300 meters. The nucleus itself remains unseen directly, hidden behind a dense coma, like a veil of dust and gas. Yet it is precisely this that makes the comet bright and alive. The most astonishing thing was 3I Atlas's spectral signature. Every comet in the solar system has its own chemical passport. And the passport of this interstellar comet is completely different. It contains too much carbon dioxide, too little water, and almost no traces of typical organic molecules usually found in comets. This makes scientists think that 3I/Atlas is a fragment from another era and another world, where chemistry and physics evolved along their own path. One could say that 3I Atlas is a letter from another star system, written not in words, but in atoms. We do not know which system it came from, perhaps from a cold cloud on the outskirts of a distant star, or perhaps from a system that no longer exists. Every fragment of its material is like an archaeological artifact left after the destruction of an ancient world. In the coming months, the comet will gradually move away from the sun. Its brightness will fade, its tail will dissipate, and it will once again become a faint point leaving our system. But before it disappears, it will leave behind an enormous amount of data. Images, spectra, tables, charts. Each will become part of a great puzzle that astronomers will study for many years to come. 3I Atlas is a reminder that we live not in an isolated corner of space. Our sun is only one star among billions, and sometimes messengers fly between them, silent yet eloquent. They carry with them traces of other worlds, stories of alien planets, and perhaps answers to questions we have not yet learned to ask.